Hi, my name is Anaya. I'm David.
Yeah.
David.
Hi, I'm Abrar.
My name is David.
Okay.
Hello, my name is Grace, and I'm going to demonstrate how to build a circuit, measure voltage, time period, and frequency in Multisim. So to get started with our circuit, we first have to place the power source, which is going to be AC power, right here. So we place this, and then we set our values, which are going to be 2 volts and 500 hertz. We're going to change the label to VS. And then next we are going to place our resistors. The value of our first resistor is going to be 1.5 k ohms. Place that there. And then our second one is going to be 2.7. And place that over here. We're going to rotate this one, and then we are going to place our ground, which is going to be this one right here, and then we can wire them all together. And then if you want, you can change the color of this segment so you can see which wires are connected to the ground and which are not. And then we set up our oscilloscope. And for channel A, we connect the positive one to R1, and then the negative to the ground. And for B, we'll take the positive and connect it to right in front of resistor 2, and then the ground to the ground. And then for our first measurement, we are going to take some voltmeters and we are going to connect it to our voltage source so we can measure that. And then we are going to change it to VS RMS. And then we're going to change it from DC mode to AC mode since our circuit is in AC. And then we are going to take another one and we're going to connect it to resistor 2 over here. And we are going to switch that to AC, and we are going to label this one as V2 RMS. And then if we run our circuit, we should get the values that we're looking for, the AC voltage values for our input source and across resistor 2, which is 2 volts for the source and 1.286 for resistor 2. And then we can look at our graph and switch both of those into AC. And then we have to scale it so that we can see the graph better. Like so. Let's make this bigger. Okay, so for our first measurement, we are going to measure the voltage peak to peak across our input source. So we're going to turn off channel B because that's the graph for resistor 2. So to measure voltage peak to peak, we can slide our graph down and we take one cursor and we set it to the Y max for the graph. And we take our other cursor and we set it to Y min for the graph. So peak to peak right here. and we can see that we get 5.68 volts for our input source peak to peak. And so with this, we can take our calculator and we can type in 5.648 divided by 2 and then multiply that 0.707 and we get 1.9965, which is our RMS voltage for our input source. And if we look, we have our RMS for our voltage source right here, which is 2 volts, and that is very close. So that is how we find the RMS for this, using our voltage peak to peak, which is 5.648, calculated to find 1.99 volts for RMS. And then next we can find our period for this graph by setting the y value to 0 and the other cursor set the y value to 0, so we have a whole period of the graph here, which we find it is 2 milliseconds for the time period for this graph. So we can take this 2 milliseconds and we can calculate our frequency for the graph, which would be 10 to the negative 3 times 2. And then the equation for frequency is 1 over the time period, so we can take that and divide 1 by 0.002, which is 2 milliseconds, which would be 500 hertz. So our frequency for the input source is 500 hertz. And then for the measurements across resistor 2, first we can measure, well, we can show channel B first, and we can measure our voltage peak to peak, which we do the same thing. We set one of them to, it should select the trace for channel B first. So take the cursor and set it to Y min, and then take the other cursor to Y max. So now we have a full peak to peak right here for channel B, which is the voltage across resistor 2, and we get 3.631 volts. So that is our voltage peak to peak. And then if we take the calculator again, and we can calculate the RMS voltage, which should match the voltmeters that we have here. In order to calculate that, we take this voltage peak to peak 3.631, and then we divide it by 2 and multiply it by 0.707, and we should get a value similar. So we got 1.2835, which is our value on Multisim is 1.286, which is pretty close to our calculated value from the graph. And then we can measure the time period for this graph as well, in which we take the cursors and we set the y is equal to 0 to the next value of 0, and then take the second cursor and do that as well, 0. So now we have a full time period here, or full period here on the graph. With each cursor set to 0, we see that our time period is 2 milliseconds as well. So again, we calculate frequency using this time period. So 2 milliseconds is negative 3, or 10 to the power of negative 3 times 2, and then divide 1 by this, which we get 500 hertz for the frequency for both of these graphs, which would make sense because our frequency here on our input source is 500 hertz, so for both of these to match, it would make sense to be 500 hertz. And that is how you take measurements on an AC circuit.
So first we'll begin our video by demonstrating how to set up our multisim work. This is what we got for our multisim. We will be using a 1.5K resistor and a 2.7K resistor. and this will be the oscilloscope results once we are done setting it up. So first, to begin the video, David and Abrar will be showing the resistor values first. So for our first resistor, we get 1.476. We'll be writing that down in our notes. 1.476 ohms. Good.
We're gonna put this one here. Then this one, the other resistor. We're gonna put this one.
We'll make sure we're not doing anything. We're not going to do parallel. We will be setting up our circuit in series. So once that's set up, it'll be easy.
So it's 2.66.
2.66 for the resistor 2. And the lab will make note that we will not be measuring resistor 1, but instead our V in, so our voltage in, for our voltage in, and we'll be measuring the voltage across our R2.
So we're gonna, right now we're gonna set up the frequency. Alright, here we go, positive, and function generator and the probe. And we need channel 1 positive. There you go. Channel 1 positive. And we start with the ground. All the ground power. Alright, now we're gonna put the frequency. Put the frequency at 500.
So for our voltage, not voltage, yeah.
Frequency
So for our frequency,
is 500.
we'll have 500, as we see in our report right here. Let me get a better view. Okay.
And we're
And then
gonna,
for our VRMS will be 2.
alright.
As you can see, we are in AC world. We'll make note to make sure that it is in fact AC world. Oh, good. Okay. So now that's all set up. There you go. So now that's all set up. We'll begin closing. And Abrar, do you want to set up the circuit? Yep.
Yeah.
There you go. And Abrar will take over. Do you want to record?
Yeah.
Here you go. I'll help set up as well.
Okay, let's prepare here first.
Yeah, I'll help record.
Now, okay, we will measure the VRMS again on my room.
Take these out so it becomes less complicated. We won't be needing these two any longer. This is our channel 1, channel 2, channel 1, show. Like I said earlier, we are in
I
series.
will say on about the supply and what is it?
Right now we're channel 1. I'll connect the channel 1 and
Channel 1 and 2.
Okay, perfect.
You recording? Yeah.
Yeah. So we're on the right side here. You can go.
Oh, I can.
This will be grounded.
The supply here.
Ground. And for our channel 2,
R2. Perfect.
R2.
The ground.
Okay. That should be grounded.
Turn on the oscilloscope.
Am I missing anything?
Yeah, function generator.
Our function generator. It's good. Yeah, we just got to. Okay, make sure we press auto. Awesome.
I need to remove that. Oh, sorry. I need to remove this. Yes.
Yeah, that looks good, right? And you can see it does represent our source right here. And we will continue now by finding our time, our Fn, and our V and P to P. Avara will be starting with
F in or
F in?
frequency.
Yep.
Yeah, frequency. So we're gonna disable the channel 2, and then we're gonna put this one in the big. All right. There you go. I'm gonna start with the position. So this is one cycle. We're gonna start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we got 10 division. 10 div times. We got this is 200 microseconds.
Right, for our time.
Yeah, so we're gonna convert it. Alright, so we're gonna use the calculator. 200 microsecond, negative 6 times 10. So we got 0.002 second, which is equivalent to 0.002 2 milliseconds.
For a period of time, right?
Yeah. So
Okay.
we got this from
Not
old
period,
school.
for a period of cycles.
Yeah.
That's the old school method, and as you can see, it also shows up on the multi-sim representation. Go ahead
And
for
now
the new
we're
school.
gonna we're gonna start new school time period. So it's showing
2 milliseconds, correct?
yeah 2.004. Alright, so we got 200.004 milliseconds. Now we know the frequency is equal to 1 by t. So we're gonna put 1 by 2, 0.002 second. We're gonna do this 1
Oh, okay.
0.00 is 500 hertz. So we got the input frequency, which is 500 hertz.
Okay. And as you can see, we are not surprised by that answer.
Alright, so we got our input frequency. Now we're gonna start with the.
Do you have to show? Oh, it's right here. Never mind.
So we're gonna start with the in peak to peak.
Is there a way to show this on new school?
Which one? This one?
Yeah, the frequency. Is there any way to show that? No,
No.
not that. This.
No. I don't think so.
You don't think so? I don't think so either. I could try over there and see. It's alright.
Time.
I want to see
You can show
something.
the frequency using time here.
Oh, you're right. Go ahead.
Alright,
Since
so
this is your part anyway,
A new school, you can.
So the
you just
peak-
press time.
Alright. Now we're gonna start with the input voltage. So first we will do.
You can just press this and censor it.
All right. All right. So we got the old school. We're gonna do old school for the V in. 1, 2, 3, 4, 5. 1, 2, 3. 5.6 division times 1 volt.
Bless you.
So it's equal to 5.6 volts. We got our in peak to peak 5.6 volt. Now we're gonna use the new school method to calculate this one. Let's see. Yeah, we also got 5.64 from there too. So this is old school V in peak to peak. That's 5 peak to peak. Now old school one is 5.64 peak to peak. So
Now to see the supply, the voltage in RMS, we can calculate this value. We're using the VPP value. We can use with the DMM and oscilloscope. But we can use the formula 0.707 plus VPP divided by 2. So using the calculator, we can use the formula. VPP.
707.
Sorry. We can use 0.707 plus VPP. We have the value here.
5.6 in our old school and new school method.
Yeah,
I say use the
divided by 2 is
1.967 or 97. My fault.
1.97
B in RMS.
V and RMS. Is that the one here?
RMS.
Is that the one right here?
Yeah.
As you can see, it represents the one we have right here.
To use the DMM
There you go.
to check this value, we calculated this value, but we can check using the DMM. To use the DMM, we can measure the supply of the circuit. We can use the direct on red to red and black, but we can capture here first. It's the same.
Yes, this is
It's the same point. So you can see the value here. 2.01
So it's basically same.
is basically the same value.
Though the results aren't the same.
And now to check, we have here 2.01 VRMS using, and now we can measure using the oscilloscope. To check here, we can press measure, select the correct channel, is channel 1, voltage, and we can select VRMS. So we can see 1.97. We can check too, whether we can use the cursor if we decided to see a manual mode too. We can decide to measure it.
I found out that you can. Fine. Oh, but I also found out that for the cursors, you can just. Can you press the cursors again?
Yeah.
Let's see.
No, I think it's fine. We got the result.
I think it's fine.
Okay, so you don't need to do.
Yeah. So we can.
Okay, we can capture on
1.97.
1.97 RMS.
Oh, that's
All right. So thank you.
To measure the frequency on R2, we need to use the oscilloscope. This is the channel 2 on R2. We need to count. We need to position the wave to count the division. So we can position and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 division, and the time is 2 microseconds. So here we have, to discover the frequency, we can use the formula frequency is equal 1 divided by base of time. This is the base of time that we find here, and we can calculate this using our best friend. So we can use 1 divided by 2 and minus 3. The result is 500. So we have here 500 hertz, the same value that we choose for use on this exercise. To find the frequency on VS, we can select measure, time, and frequency. So here we have the frequency. Now to find the frequency across the R2, we need to measure the tape, and we need to measure time, frequency, and here we have the frequency, the same frequency that was use it on function generator.
Right. One. Start.
Sorry. So first, I'll be demonstrating how to use the DMM measurement first for our resistor 2. Simply positive to negative, negative first, negative, and
So it's gonna
positive.
connect the channel to
Let's see
DMM.
what we get here. We get
Resistor
1.29 for resistor 2, 1.30.
Oh, yeah, you got one.
Resistor 2, that's also what we got from over here.
1.30.
I begin disconnecting. Now I'll show how we get our, the next one would be our
V2 RMS on
V to
the
our mess. Yeah. So first, I'll do it
on the
old school first. So first, to get our V to RMS, we'll press measure. We'll press, not measure.
yeah. I think you
This should
can
be time. V to RMS.
no on the other one.
Is it that one? Oh, it's on voltage?
On the voltage.
Oh, you know why? I got you. That's my own fault. Channel 1, channel 2. Okay, voltage and then V2 RMS. Okay, it'll be 1.30.
Yeah, it's almost the same. So 1.30.
It was damn near the same, right? Okay, so after we got our V2 RMS, which was 1.30, it should be volts. Now we'll start with our V2 P to P. Make sure everything is lined up. All you simply do is count 1, 2, not lined up, yeah. 1, 2, 3, 2, 4, and 6. You simply write it down. 3.6 V times 3.6 V times our 1 voltage source. Be 1, 0 V. And this was also division. My bad. Those are division. Cancel that out. We get 3.6 V for our voltage. RMS for our voltage source. Is it? No, VPP. My fault. I put the wrong thing. Now to show our new school style, you just simply go to measure. You will go to voltage. And you go to V2. Here, 3.7. Not exactly the same, but it is near it. Go. So that's correct. And now we'll do our period of time, which is simply the same as the other one. You would simply make sure everything is lined up, make sure everything is even. You go 1, 2, 3, 4. 4. Before DIV. 4 V DIV times
500
yeah, 500 times microseconds. My fault. Microseconds over DIV. Cancel. Calculator. All you simply do is 4 times 100. Oh yeah. Make sure it's in this. E, -6. You get 0.002. And if you want to convert that, 10 to the third. 0.002 times. Easy equals 2. And as you can see, it is the same as our channel 1, but throughout the experiment, my fault, 2 milliseconds. But so throughout our experiment, we found, not experiment, throughout our lab, we found that the period won't change throughout the experiment. It won't change. It will only change to frequency, but any other factor, including our V2CP and V2RMS, won't change this.
All right. You wanna show in there the period?
Yeah, I got you.
All right.
So now all you simply do is this method. You go to time, press period, and 2.00 mm.
Oh yeah.
Microseconds. Yep.
All right. Thank you.